Factory design pattern is a creational design pattern that provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. It decouples the creation of objects from their use, making the code more flexible and maintainable. So we will take one example. So based on the pizza type, this pizza factory will create the pizza object. So if type is given cheese, it will create the cheese pizza. So at the client code, we can mention the pizza type to create the abstract factory design pattern is a creational design pattern that provides an interface for creating families of related or dependent objects without specifying their concrete classes. So in this scenario, we will create a UI toolkit that supports different operating system, that is Windows, Mac and Linux. So the abstract factory, the widget factory will provide the different OS factories based on the OS type, and the concrete factories will create the products that are builder design pattern is a creational design pattern that separates the construction of a complex object from its representation, allowing you to create different representations of same object using the same construction process. It's particularly useful when constructing objects with many optional or mandatory fields, or when the construction process is complex or may require a specific order of actions. So, in this example, we will use a car builder to create the car object. Prototype design pattern is a creational design pattern that allows you to create new objects by cloning existing ones. It's useful when creating an object is a costly or time consuming process, or when you want to avoid the complexity of class creation. So in this scenario, a document editor that allows user to create new documents from existing templates. So we will implement the clone method to clone the document. Singleton design pattern is a creational design pattern that ensures a class has only one instance and provides a global access point to that instance. So we cannot create multiple objects of that class. There are different ways to create singleton classes. One is eager singleton, second is lazy singleton, third one is double checked locking singleton for the thread safety. Then we can create a static block singleton in the static block, and the final we can create singleton via adapter design pattern is a type of structural design pattern that allows objects with incompatible interfaces to work together. It acts as a bridge between two different interfaces, making them compatible without modifying their source code. So we will take an example of a music player that can play MP3 files but needs to play other formats like WAV or AAC. So we will create a media adapter, and in their adapter play method we will call the adaptees play function based on the file type. Bridge design pattern is a structural design pattern that decouples an abstraction from its implementation. So it separates a class into two hierarchies: abstraction that defines the high level interface that client use, and the implementation that defines the concrete details of how the abstraction is realized. So this example, we will create a drawing application that supports different shapes like circle, rectangle, square, and the drawing methods like pen, brush, or fill. So the shape class is not dependent on the drawing apps concrete drawing API. It depends on the abstract drawing API. A composite design pattern is a structural design pattern that allows to compose objects into a tree-like structure. It treats individual object and composition of object uniformly. It also enables clients to work with individual objects and composition of objects in the same way. So in this example, we will build a graphical user interface with components like windows, menus, buttons, and text box. So we will have one component, and all component will implement these component. So for the composite component, again it will implement the same component. The decorator design pattern is a structural pattern that dynamically adds new features to existing objects without modifying their original structure. It promotes loose coupling and code reusability. So in this example, we will have a text formatting in the word processor example scenario. So we will have a concrete component, plain text, and the formatter we will use as a decorator class. Facade design pattern is a structural pattern that provides a simplified interface to a complex subsystem. It acts as a front-facing wrapper that hides the internal complexity of a subsystem and making it easier for clients to use. So in this example, we will talk about the home theater example. In home theater, we have different components: amplifier, tuner, DVD players, home theater. Facade will combine all of them and create a unified interface to interact. Facade design pattern is a type of structural design pattern that minimize memory uses by sharing a large number of similar objects. It achieved by sharing the common state of objects and storing only the unique state separately. So we will take one example of creating a forest with thousands of trees. So based on the tree type, we will create a hash map and store the tree by type. When user want to create an object based on the tree name, we will fetch that object from the hash map and provide it to the user. So tree factory will contain the hash map of tree types. A proxy design pattern is a structural design pattern that provides a surrogate or placeholder or a proxy for another object to control access to it. It acts as an intermediary, intercepting calls to real objects and potentially performing additional actions before or after forwarding those calls. So we will take one scenario of image loading in a web application. The image interface defines the common operation for both real image and the proxy image. The real image class load and display the actual image from the disk, but the proxy image class act as a proxy delaying the loading of the real image until it's actually needed. Chain of responsibility design pattern is a type of behavioral pattern that allows multiple objects to handle a request in a sequential manner. It creates a chain of potential handler, and each handler decides whether to process the request or pass along to the next handler in the chain. So we will take one example of handling error logging in a system. The logging interface defines the common operation of handling log messages. The concrete loggers like console logger, file logger, email logger implement the logging logic. The class, the client set up the chain of responsibility by linking loggers together. When a log message is sent, it travels through the chain until a handler processes it, or the command design pattern is a type of behavioral pattern that encapsulate a request as an object and allow the request to be treated as a data structure. It decouples the object that invokes an operation from the object, and it promote loose coupling, flexibility, and extensibility. We will take one scenario of remote control for a TV. So TV command interface defines the common operations for the commands like execute or undo. The concrete commands like TV turn on command, turn off command encapsulate a specific action for the TV. The remote controller, the invoker, holding the commands and executing them. The TV is the receiver. The perform. The iterator design pattern is a type of behavioral pattern that provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. So we can take one example of iterating our collection of books. Book collection interface define the create iterator method to provide an iterator. Bookshelf implement the book collection and manages a collection of books. The bookshelf iterator implement the iterator and traverse the book in the bookshelf. The client uses the iterator to access the books without directly accessing the bookshelf internal structure. So iterator has methods, has next and next method. Mediator design pattern is a type of behavioral design pattern that reduces the coupling between multiple components by centralizing communication through a mediator object. Mediator encapsulate the interaction logic and promoting loose coupling and flexibility. We will take one scenario of air traffic control system. In this, air traffic controller will act as a mediator, and all the components, the airplanes, will communicate through the mediator instead of directly talking with each other. Memento design pattern is a type of behavioral design pattern that allows an object to capture and restore its internal state without revealing its internal structure. It achieves this by creating a memento object that stores a snapshot of the object's state. So we can take one example of text editor with undo and redo feature. So text editor act as a originator, creating mementos of its text state. Text editor memento encapsulate the text state, hiding it from the other objects. The editor history act as a caretaker, which manages the memento and enabling undo and redo. Observer design pattern is a behavior pattern that defines one-to-many dependency between objects, where one object notifies multiple other objects that is observer about state change. It creates a subscription mechanism to dynamically manage observer and update them when the subject changes. We will take one example of weather monitoring system with multiple display types. So weather data will have list of observers, and observer can register themselves on change of any measurement. It will notify all the observer who has registered to it. State design pattern is a behavioral design pattern that allows an object to change its behavior when its internal state changes. It achieves this by encapsulating the state specific behavior within separate state classes and delegating actions to current state object. So we will take one example of vending machine with different states like no coin, has coin, or sold out. So vending state machine interface define the common action for all states. The concrete implement the action specific to each state. The concrete states can be known no coin state, has coin state, sold out state. The vending machine hold a reference to current state and delegate action to it. Strategy design pattern is one of the important design pattern. It comes under behavioral design pattern, and it defines a family of algorithms and encapsulate each algorithm within its own class and make them interchangeable. It allows algorithm to vary from clients that use them. So we can take one example of having different sorting algorithms. The sorting strategy interface define the common sorting algorithm contract. The concrete strategy implement different sorting algorithms like quicksort, bubble sort. The sorting manager hold a reference to the current strategy and delegates sorting to it. Strategies can be changed. Template method design pattern is a type of behavioral pattern that defines a template for an algorithm in a base class, deferring some steps to the subclass. Subclass can then redefine those specific steps without changing the overall structure. So we can take one example of making coffee or tea. So beverage class define the interface method like prepare the recipe, which outline the algorithm step like boil water, brew, pour in cup, add condiments. The concrete subclasses override specific steps like brew or other methods. The base class control the overall algorithm flow and ensure each step is performed